Good evening. This is meteorologist TT with the Snowstorm Podcast for Sunday evening, February 11th. It's 11:30 here in the east, 10:30 Central Time. Lots to talk about here in the pattern, including what's going to happen in the last month of the winter, maybe a month and a half, and it's not looking very good. So let's get right to it. This year's the snowstorm matrix, and everything is pink. Yeah, if you look at the model data, there's very little data here over the next 10 days, which supports any sort of accumulating snow over any portion of the Midwest, the Ohio Valley, the interior Northeast, on 95, and of course the Deep South. There's nothing going on. And we'll get into why that's the case, but that's a pretty bleak looking snowstorm matrix map, table, I gotta tell you. Here's the radar here as of 11 p.m. this evening. You can see the next batch of this rain coming up from the Deep South. That'll come up later on tomorrow. And it's right in this area right here. And you can see it's generally going to go, in this direction as thus, and mostly hit the southeast third of Virginia, the Delmarva, and much of eastern North Carolina. Those areas have not seen the big rains here recently, so that's kind of significant. And we can see that here on the short range NAM. This is at 5 a.m. A lot of rain here over central Virginia, Richmond, into eastern North Carolina, Hampton Roads, the Delmarva. And then this here is 9 p.m. Yeah, 9 a.m. I should say, on Monday morning. You can see again a lot of rain, almost back up to D.C., but definitely over the northern neck and middle peninsula, Richmond, Hampton Roads, the Delmarva, far southern New Jersey. There you go. So it's a pretty decent rain event coming in here for the second tomorrow morning. So now, if you're in the Piedmont, you may get a little bit of rain here up at D.C., the valley, but mostly this is a central and eastern and southeastern Virginia type of thing, as well as eastern North Carolina. And this gives us the total rain on the NAM the next 60 hours. And you can see the pretty good rains here over eastern and southeastern Virginia. And even beyond that, this is the 6 to 10 day. Yeah, there's more rain coming up here for next weekend too, so that's not looking great for President's Day. All right, again, this is the matrix. You can see there's nothing going on here. I just want to show you that in great detail. It's just nothing going on. Everything is no snow. That's what the pink means. Let's talk about the polar vortex now. There's been a lot of talk in the weather community of the polar vortex splitting. Here it is, the polar vortex splitting into two pieces, and a lot of strange readings going on in the Arctic region. And there's an event known as SSWE, and that stands for Southern Stratospheric Warming Event. So that's referred to. And this is a relatively new thing in here. And if you're a meteorologist or a weather hobbyist or weather weenie, you probably know about this term for the past 10 years or so. But it's an important feature. Now, this is what the polar vortex typically looks like. This is what it typically looks like during the winter. It's one big piece right here, and it's centered over the North Pole or close to it, maybe sometimes in northeastern Canada or northern Greenland. That's what it typically does. Now, every so often, the polar vortex, of course, will shift. And when it does, it has significant implications for the weather pattern. So this is when it splits into a couple different pieces. Now, in this particular case, what's happened is the one piece of the polar vortex has moved here, and the other piece has gone down in this area, thusly. And of course, by doing this, it drives cold air into the U.S., potentially, and into central Russia or into China, Japan. Now, every polar vortex is different, and it splits up in different areas. So over the last 2 weeks, maybe 3 weeks, there's been strong indications from the various weather models. And I talked about this in the last update of the polar vortex undergoing a sudden stratospheric warming event. In other words, warm air would come up from the equator at the upper levels of the atmosphere, in the stratosphere really, and cause the polar vortex to shift and break it apart into different pieces. Now, this is what's actually the polar vortex looks like right now. This is the very top of the atmosphere, almost on the edge of outer space. It's 10 millibars, about like 50,000 feet up there. I mean, it's really up there. And you can see that the polar vortex is split. So this here is our bubble of warm air right here. And one of the polar vortex is split, and now one piece of it's here over in Europe. So this is Spain. Okay, here's England and Scandinavia. You see this? And over here is Greece, and this is Turkey, so this is Russia. So the piece has gone here. Now, the green here, look at the green. You can see this is North America. There's the east. This is the west coast here. There's Hudson's Bay. Here's the east coast. Okay, you got your bearings? Good. Now, here's the polar vortex forming here. and it's in northwestern Canada. Now that's not a good sign. You need this polar vortex to come over here, not here. That's not good. So in any event, that's part of what the problem is. So there's a general assumption by a lot of weather hobbyists, weather weenies, and meteorologists who engage in hysteria and hype that every sudden stratospheric warming event means it's going to get cold and snowy for the East Coast. It is possible that can happen, and there have been some sudden stratospheric warming events which have changed the winter and caused it to turn stormy and cold for a prolonged period of time. But it doesn't happen only that way. There are other possible results. To give you another version of this, I changed the alignment here so you can see more of North America. So again, just to show you what I'm talking about, this here's the West Coast, here's Alaska, see that? This is Hudson's Bay, this here's the East Coast. So the vortex goes here, and this one's over central Russia. And this is the bubble of warm air which is split it apart right in here. Okay, good. So if we look at the actual upper atmospheric pattern, now this is the pattern here from the 12Z European model, and we can see two very distinct polar vortexes. One is formed here, and another one is formed here. And what's happened is this is pushed up into this direction, and it's split it into two pieces, sort of like a lava lamp. Very much the same sort of thing. So there you go. And now the problem is, of course, is that there are other factors in here, and again, you'll see that because the way this polar vortex is shaped or developed, it's not favorable for the East Coast of the United States. We'll get to that here in the next slide. Now, this is 84 hours out, and what's happened is, let's call this up. Here's the first polar vortex here, and there's the second one there. Now, the problem is that this polar vortex is forming over here in this part of Russia, in the eastern portion. So what that does is, this vortex causes a ridge to form in the northern Pacific Ocean by Alaska. Okay? Remember that for every trough, there's a ridge, and for every ridge, there's a trough. So because we have a big upper low here, we get a ridge here. See that? That produces a trough over the west coast, and that produces a southeast ridge. And that's what hurts the winter. You're getting southwest winds, cold air can't come southward, and you're getting a lot of rain when the cold fronts do try and come south. So this is why it doesn't work out, sometimes with the sudden stratospheric warming. Now let's look at our teleconnections. Well, okay, over the next 2 weeks, the PNA, which is strongly negative, still stays negative and close to neutral by the end of February. The NAO, which is strongly positive, gets close to neutral by the end of February, but just neutral. And this is the GFS showing this. There are other projections we'll show you in a minute, which is different. And the Eastern Pacific Oscillation, which is negative, goes to neutral. And then remember, it's the Eastern Pacific Oscillation which allows the ridge to build all the way up to Alaska and pull the cold air down. We need this to be negative. And if it's going positive, that's not a good sign here. So there you go. So we got problems with the pattern. Now, this here is looking from the European, and you can see the European, the Arctic Oscillation. Look what it does. Again, we're looking at the green, the mean here. Strongly positive, gets neutral by the end of February, February 26th. This here's the NAO. Strongly positive, barely goes negative by the end of February. That's not good. You need both of these things to be really negative, and they're not. And then if we go beyond that, we go to look on the Pacific side of things. Okay, here's our Eastern Pacific Oscillation. Remember, we want this to be negative to bring in the cold air. And what happens? It's negative, and then it goes positive end of February. Well, that's not what you want. That's bad. And then the PNA, remember, we want a ridge on the west coast, right? We want a positive PNA here. We want a positive PNA. And what happens? Again, looking at the green, it says strongly negative the whole way through the end of February. So this is bad. This is just not looking good. If we look at the maps here in more detail, focusing just on North America, we can continue to see next week we have this big vortex here, and the ridge is still over Alaska. This is the symbol for the ridge, and that places the trough here on the west coast, and there's our southeast ridge, and it remains there the whole time. This is now Friday, February 16th, and there's your polar vortex of a trough here, and you're getting southwest winds. So there's no cold air coming southward here, folks. That's not happening. And here comes the next piece of energy coming to the western United States right there. Not good if you like winter weather in the eastern United States. No doubt about that. All right, slide 19 here. Now this is the 96-hour pattern, and you can clearly see two very distinct polar vortexes. One here, one here, and the ridge is here, and it's here. And that is placing the mean trough on the west coast on the Rockies, which means the southeast U.S. ridge. And that is a big problem. To get that to change, it's going to take a lot of work. And we're running out of time. This is day 11. Look at this ridge on the southeast. I mean, holy mackerel. Here's your trough, like we said. Sure, here's the polar vortex. It's strong and it's big. It's way to the north. And here's your ridge on the west coast. Remember, there's a symbol for ridge. In Alaska, that places your trough here, and there's your southeast ridge. That's a bad pattern. Now we look at this hemispherically. Now this is the GFS 1 to 5 day. Okay, and we can see the anomalies here on the reds and the blues very nicely. Here is one polar vortex. Here is the other one. There's one, again, this is the warming, which is pushed up. We have two ridges, but this ridge is over Alaska, which means the trough is over the west coast of the Rockies, which means the southeastern U.S. ridge. And you're not getting cold air coming southward. And because of the southeast ridge, this polar vortex is way far to the north of Hudson's Bay on Baffin Island, the big island north of Hudson's Bay. This is a bad pattern if you like winter weather. It just is. So that's the problem. That's the 1 to 5 day. And if we look at our temperatures, let me clear this out. Here are temperatures. This is the 1 to 5 day temperatures. You can see there's some little cold air in Canada underneath the vortex. Look, here's our vortex. So you naturally underneath here, it's going to be cold, obviously. And sure enough, that's exactly what we see. There it is, the cold. Okay, fine. And the other vortex, which is in Siberia, there's the cold in Siberia. Okay, great. Here's the 6 to 10 day. Yes, this is from the European ensemble. And again, not much has changed. One polar vortex here, one polar vortex there, and the ridge is in Alaska. That means your trough is on the west coast of the Rockies, and look at that southeast ridge. Not good. Not good at all. And when you have a vortex this big here, this means the NAO stays neutral or positive. That's also really bad. And now this is the GFS of the 6 to 10 day, and it's showing the same thing. There's your southeast ridge. Look, here's one vortex. Here's the other one. There's your Alaska ridge. Your Alaska ridge is right here. There you go. This pushes up this way, so there's our split. But again, this keeps that ridge in place. And there's your southeast ridge. Just not a good pattern. This is the 6 to 10 day European ensemble. Same sort of thing. Now, this is 11 to 15 day, European ensemble. And what has changed here? Has anything changed? No. Ridge, no. Trough here, ridge southeastern U.S. No, it hasn't changed. Now, you got a bit of a ridge here in Scandinavia and Iceland, which technically counts as a negative NAO by some people, but that's not really a negative NAO. That's what I call an Iceland and Scandinavia block. So, and if we go looking at the temperatures, here's the GFS ensemble mean, 6 to 10 day temperatures, and you can see. I think I looked at that slide already. And then this here is the 12 to 16 day. And again, nothing has changed. Southeast ridge is still there. The ridge in the northern Pacific, Alaska is still there. And these are our temperatures. Look how warm they are. 11 to 15 day on the GFS ensemble. And if we look at the MJO, which was the hope earlier, okay, the MJO, remember, we wanted to go to phase 8, which is in February, which is like favorable for snowstorms. Well, here it is now, February 10th, and it was doing phase 7. Now it's done a little hook. See that? Now this is, remember, when it's on the edge of the graph here, the MJO is very, very strong. And this is the neutral circle when it's very, very weak. So this is still a pretty strong MJO. But look what happens here. Now this is the this was the Australian model from February 8th, last week. And it showed a weakened, and then it kept it strong, moderately strong in phase 8 and phase 1. So this was promising from last week, and it gave us hope that there might be a change which could result in the pattern into more winter weather. And this is what phase 8 looks like in La Nina, and this is what it looks like with phase one. And you can see this is a snowstorm pattern here. This favors a strong low on the east coast, and this one also favors a strong low on the east coast here also. So that was good. But here's the new data. This is new, okay? Let's look at the data here. This is February 11th. This is February 11th. Look what happens. It collapses it and goes into the neutral circle on the edge. Very weak in phase 8, very weak in phase 1. Here's the other European, and you can see the same sort of thing. It's so the both of them, the European ensemble, they're both doing the same sort of thing. Here is the GFS. It also weakens it. Now it only goes out to February 25th, but the GFS clearly shows a weakening trend heading towards a neutral circle here. All these factors are showing that the MJO is going to break down, and if it breaks down, the last hope for the pattern turning cold and stormy in the eastern United States in late February, early March goes with it. So it's not a good sign. This is not a good sign of trend here with this latest data and latest information. And finally, the last thing I want to point out here was the Rossby wave model. And you can see this. Now, I pointed this out a couple of weeks ago. It had a big negative anomaly dropping south over eastern United States, indicating a huge trough and an Arctic outbreak. If you look at the data now, it's completely gone. There's nothing here at all. It's actually a ridge over the eastern United States right through into the early and mid March, into almost the end of March. So even the Rossby wave model, which earlier had a huge negative anomaly over the eastern United States, that's gone as well. So there's little reason to be optimistic about anything happening the rest of this winter. I'm not going to officially kill it yet, but it's getting there. It's getting close. This is meteorologist DT from weatherist.com. I'll talk to you soon.